Okay, we want to try and see how to replace two resistors in series with one resistor that does the same job. So let's see what the definition of resistances in series is. If you put two resistances in series and there's nothing else connected here at point B to any other resistance or battery or whatever part of the circuit, then the current going through this resistance is exactly the same as the current going through this one. Remember, the current is the same through any wire, as long as you don't have any other branches here. So the definition of two resistances in series is that the current has to be the same. There cannot be anything here going connected to B. So if you think about this circuit that has a battery and two resistances in series, can you just map out what the potential is at different points in the circuit? Try and color the potential everywhere. See where the parts that have the same potential, which parts have different potential, put a different color. So we'll do that by putting blue here. All this is blue, the potential is the same. This is an ideal wire. Once you go across the battery, the potential changes to a different value. So the potential here is all green. It's an ideal wire. Once you cross the resistance, you get a different value of potential. So the potential here is all the same, it's all black. This is just to kind of give an idea what the potential looks like, what the value of the potential at different parts of the circuit. So let's ask the question, let's try and get the potential difference across this resistance plus the potential difference across this resistance and see what it's equal to. So what's VA minus VB? Now we know that the current goes from high potential to low, so VA minus VB is just I times R1. And we know VB minus VC, the current goes from high to low, so the potential at B is bigger than the potential at C, so VB minus VC is I times R2. Now if you add these two equations, you get the minus VB and VB, they cancel, and you get VA minus VC is equal to I times R1 plus I times R2. So the potential difference across the combination of resistances, which is just the sum of the potential differences across each one, and you get this equation for the potential difference across the combination of resistances. It's just IR1 plus IR2. So now what we want to do is we want to remove these two resistances and put one that does the same job, called the equivalent resistance. What do we mean by the same job? It means that for the same battery, it provides the same current. So what does that mean? It means that VA minus VC in the equivalent circuit equals to I, the same current, times R equivalent. So we have this equation for the resistances in series, we have this equation for the resistance, the equivalent resistance. And VA minus VC is the same in both cases because VA minus VC is the potential of the battery, and the battery is the same potential. So these two equations can be equated to each other. We get that R equivalent is I times R1 plus I times R2. The current is the same. And so this relationship for the equivalent resistance for two resistances in series, you just replace them by one resistance that has the sum of the resistances